All right, good evening, everyone. This is Eric Whiting. I wanted to give everyone a walkthrough of LuluPerfTest, which is the software system I built in conjunction with my thesis. I'm just making this so that if you guys wanted to go through the code, you don't have to click through it all yourself, and I can kind of tell you where things are and how things are supposed to be working. Um, so yeah, I guess I'll just dive right in. So LuluPerfTest is a performance testing tool, and the basic idea for it is it runs performance tests, or excuse me, it runs automation scripts in in some threads, and then in other threads it runs uh, monitoring scripts, I guess you could say. So basically, you give LuluPerfTest a list of scripts that run a browser or something automatically, and while those are running, the LuluPerfTest also watches something like the CPU usage or disk space or memory of the system and records it back to you in whatever intervals you've asked for. Um, so, and just in case I wasn't clear about what an automation script is, so I have a test bed. This is my test site. I believe I sent the link for this. I can run this on AWS if I need to, but right now it's running locally. And what I have is a bunch of browser automation scripts that will run through different actions as I without any human intervention except for me initiating the run. So if I run this Ruby class over here, it's gonna open in the other screen. Hang on. Do 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 do. Okay, so it's running. So I didn't click anything. That's the script did all of those flashy things you just saw by itself. Okay, and that's because it's a browser automation script. That specific one was written in Ruby with waiter or water. I don't know. But yeah, so these are really popular in Agile. I'm sure you guys know this, but I just wanted to make sure, just in case you don't. These are really popular in Agile because you can act like a user and click things and expect things and all of that. And you throw it into a build or a test suite and forget about it. So the way LuluPerfTest works is it runs a script like that while also watching system performance, like the memory usage or the disk space, and um, and the idea here is that users can write their automation scripts. They can know already how many what their user loads are like, so they can go ahead and say, I want 1,000 users running this test script at whatever interval. I want 200 test users running these scripts at this interval, and they can kind of like fine tune their load while monitoring uh, the system performance. And yeah, so that's what LuluPerfTest, or I'm probably just gonna call it LPT from now on. That's how that works. And so let me just go ahead and show you how it's built. So if you pull the project from the repository, which is in Eric-Whiting / LuluPerfTest on GitHub, in the prototype module or package, I am not a Java guy, so I'm not real great with the terminology. I used Java for this because I needed good threading and good class like class data type enforcement, and I can't really get that from Python and Ruby, which are languages I'm a little bit more comfortable with. So forgive me if I use the wrong terminology. But anyway, so if you go to the prototype package, there is a bunch of stuff, a bunch of prototypes that kind of show off the different parts of the system and how they work. And these are what I developed as I was developing the system itself, so that I could play around with it. Um, but yeah, so this is how this works. Um, there are there are classes. There's an abstract class called metric monitor and that implements a monitoring interface, and there's 4 concrete classes for that. And what they do is they basically just watch different system metrics, I guess. Like as you can see here, there's the memory monitor, disk space monitor, and CPU monitor. So let me just go ahead and show you how those work. So first of all, the monitoring interface, all of the different metric monitors implement this interface. And they'll all have a double for monitor and stop monitoring methods. And then the abstract class implements monitoring as well as runnable. And runnable is a Java built-in from the standard library that allows you to run these things in their own threads. And so it has a monitoring. All of these guys are going to have monitoring methods. They'll all be in the actual concrete classes. And the monitoring is going to be called in the run method, which is the which is when you implement runnable, the run method is what is running in its own thread. So yeah, so that's what that is. Um, it's got some other stuff. I think a lot of this stuff I ended up not using. It was kind of stuff I thought I would need, but yeah. So anyway, so one of the concrete classes we have here is the memory monitor, and so memory monitor obviously is going to extend the metric monitor. So it's got the monitor method like it's supposed to, and this just has this little formula that gets the current memory usage and returns it. And right now I'm system outing all of the results. In the future I would like to write those results to like an Excel sheet or a database or something, but I won't get into that right now. So this is how the different monitors work. These classes, there's the disk space monitor. For the disk space monitor, you actually have to pass in the directory you want to monitor, because maybe you want to monitor like a download folder or a temp folder while some kind of scripts are running. And then there's also the CPU monitor, which just monitors CPU usage, as you can imagine. And then there's the other monitor, and this has everything else except what you would do in this case is pass it a command, and it would have to be a system level command that is what you want to use to monitor some kind of system metric. So in Linux you can monitor the CPU usage or the disk space or with different commands. If there was something else you wanted to monitor, you could do that by creating another other monitor and pass it a command and give it whatever command line command is needed to get that, and it uses buffer reader and all that stuff to get that. All right. So and then there's an aggregate class, I guess you would call it, that has a collection of metric monitors, and this is kind of for management, so that we can make a bunch of monitors and then start them and stop them all at once. This private method is what turns the monitors into threads, and it goes through the threads and hits their start method. In runnable starts the run command, and yeah, that's what you get. Oh, and I also meant to mention that there's a metric checking frequency in the monitor classes that it's how the user tells the monitor how often to pull that metric. So otherwise it would just be like every millisecond be giving you that result. Otherwise, I think I saw I did in my prototype, I did 500. Yeah, so that's half a second. It's 500 milliseconds, I think. Anyway, so that's how the monitoring module works, and I'll just go ahead and show how that works. So these 3 things will run for 10 seconds, and it just keeps telling you what the memory usage and what the CPU usage and disk space of of the C drive are, and then after 10 seconds, it gets the stop command because I hit stop monitoring, and that's how that works. Okay, so that's the monitors, and then there's the use cases package that this one is kind of a little bit more complicated. So let me close out these guys, and I'll show the prototype first. Okay, so for example, this Ruby, uh, that Ruby script you saw me running earlier, we pass it the it's commented out right now because so the Python scripts are headless. I intentionally made them headless so that it wouldn't take up um, a bunch of memory, or so it would run faster when I was testing these out. But anyway, so the way that the use cases are used is we give a path to the scripts, to those use cases scripts. So in this case, these are paths to like this script, and we pass those to a use cases class, and we start those, and we can tell it to run one or two um, threads, and so this is where we get to the point where we're like, okay, explore albums. I want, in this case, I have one person doing that, but I could have 10 or 100 or 1,000 users doing that at one time, so that I can like really tweak my load, my my user load. So I'm not sure was there. I think that's a debugging statement, but anyway, oh gosh, I hope this works. So this is the prototype for the use cases. As I have some logging going on, and these are running the different scripts, and they're running all together, and I also have a log output going on right here. Yeah, so these are the headless scripts that are still working. That's why there's still some output going on, because it's not quite done running yet. Oh, I have an error too. Yeah, so obviously it's not perfect. And that's actually an error in my scripts. But anyway, okay, so yeah, that's how the use case module is used. So let me show you how it's actually like implemented. And what is that? Is that any different? Anyway, okay. So use case is kind of the main class we have here, and we have a name, a path, and a command to run the script. So before you saw me run the Ruby script by saying Ruby path, right? So that's what the command to run script is. It would be Ruby or Python or anything, as long as it can be run from a terminal. You can pass it the command to run it, and pass it the path to the script or whatever else you need to do. So, and then we also have the number of threads, and then this I'll get to in a second. So it just builds out. So this is the constructor, and then when we run it, um, what we do is we build these use cases, these runnable use cases, and that builds a bunch of instances of this class called runnable use cases. This one is actually implementing runnable, and that is where the threading comes in again. So when we hit run on these use cases, first we log that we're running it, and then we use this line of code right here is how you in Java how you run a terminal command, and so it runs, and then there's some error handling if necessary, and then when it's done we hit the is running false, which is used I think in the use cases. Yeah, this is how we find out if all of our instances are done. So a use case is one instance, but you can have several threads for it, right? So we can have 500 people running the same use case. And one of the things about that is in the use cases, at least on the ones I made as an example, we have elements of randomness. Is that in here, or oh yeah, so we have things like linger, get distracted, go to bathroom, go to lunch. These kind of so these are like trying to get a randomization and hone in on kind of a typical human usage. And if you're writing the test scripts, you can obviously um, tweak that however you want. Yeah, so in the test script, we have linger after he does stuff, and then right before he closes the browser, he gets distracted, whatever. So anyway, so that's how we get some kind of randomization and kind of mimic the real world. Um, and but that was in the test script, not so much the LPT system. So that's how use case works. It runs these runnable use cases. There's another aggregate class called use cases, and again, that's for management, for managing use cases. It just builds an array list of use cases, and I don't know why I didn't use collection here. But since this is all internal, the intended users will never actually work with the Java code. They're actually going to work with the DSL code, and that's what I'll get into next. And the DSL code is how a user is going to define how they want these tests to be built. So I wrote a YAML and a JSON, but here is the I ended up going with JSON just because it was easier to work with. So okay, so here's how it works. This is something that I intend a user to be writing, right? So a user writes a performance test. He can name it if he wants, and then first he defines his use cases, and you can name them. You do the script. You tell me the command to run the script and how many you want, and then you say what you want to monitor, right? And this is the extent of what the user would do to get what we just saw, where it was running those use cases and then also the added thing of monitoring those metrics. So I believe I have a yes. So this is kind of how this is getting closer to the user facing stuff. I should delete that. So we give it the path. This is a prototype. So we give it a path to the JSON, the DSL for the use case, or for the performance test, and then we use the DSL parser class to get the JSON, and then this parser class is going to build out those monitor classes and those use case classes that you saw. And then in this prototype we hit start. And actually, does this work right now? This might not actually work right now just because of what I was developing. Okay, so these are running. It's monitoring the system. The doesn't look like it's actually doing anything right now, but that might just be because they haven't started yet. Do I need to close this out? Okay. Well, okay, so I don't know what's going on right now with all of that. But anyway, so the DSL parser is going to go through the JSON and figure out from the JSON, it's going to build out the monitors and the use cases and everything. So, and then once it does, there's something called DSL runner that's going to run all that stuff. Yeah, this is a little embarrassing that didn't work, right? But it'll work when I present this on the 16th. I'm just trying to give you a walkthrough of the code right now and to see how it works. So yeah, so that's how the DSL class works. Nothing super groundbreaking right here. It just uses that JSON file to build out the monitor classes and the use case classes here, and then the DSL runner just hits run on all of those. Well, it hits run on the parser class, which hits start on the use cases. Anyway, so then finally, the main class is super simple, and all it does is it's going to take in a string of one or many. It depends on what the users do. Paths to similar JSON files, just scripts to the DSL of the performance tests. Excuse me. And then just run them, because the DSL runner, the new command, includes the run command, so it's just a couple of lines. And so how this is going to end up working, the way I picture it working in the real world is, we have this, say for example, we have this web app. This is the source code for this, for the test site, and this is written in Flask. And what's going on here is, in Flask we have, what you do to make tests is you have a test folder, and you put for example, you put a unit test in it, and uh, every time you push a new commit, this is going to run test case. It's the build server is going to run all the test cases. So just real quick, let me show you how that works. So anytime I make a commit in GitHub, and I make a commit on my computer and I push it to GitHub, if I have it wired up to Travis CI or Circle CI or whatever, um, uh, every time I push, it's going to trigger a build, and in this case, I'm using Travis CI. Travis is going to run all those test cases that we give it. So Travis runs these anytime I make a commit, but then also in my test folder, I have the jar of LPT, and then I have a DSL. It's the same, DSL. It's got links to locally to these test scripts that are over here, and just running the test scripts, and oh crap. So it has all of that, and so what you do with CI is you make a build script, or no, not the build script. For Travis, it's still called a build script, but it's a .yaml file, and you do all this stuff. This is all kind of like boilerplate stuff. You tell it the Python version. I tell them that I need Postgres to run, and I need Chrome, because it's going to run those automation scripts. It actually needs Chrome installed on the build server in order for that to work. This is just installation stuff. We know that we need Flask and scicop pg2. This is not best practice. Usually in Python you have a requirements.txt file that installs all of the all of the dependencies, but I didn't have time for that. I just kind of did this by hand. Oh my gosh, this is going long. I'm sorry. So yeah, it goes through all of this, and then when it's done, it runs this thing called script. It runs the script tag. This is just how you run all of the tests in Python, is this command right here. And then this is where it's LPT specific. So it runs after script. We're going to change the mod of build, because the build sh, the shell file, this actually builds the app. It does the update. It installs everything, and so we're gonna run that in here, and then we're going to change the permissions on the jar file so that we can actually call the jar file, and we're going to run the build script, and then this was a debugging statement, sorry, and then we java jar the jar so that it'll work, so that it'll run, and we pass it the path to the performance test. And what'll happen is, let me go ahead and make a change so that I can trigger a build and show you. So commit that, and now we push. So that's gonna push to the repo, and it should change this. This should change from 4 days ago to like a few seconds ago. Yeah, 15 seconds ago. And now that it's pushed, Travis CI is going to trigger a build. It's going to start building. This will probably take about 3 minutes. So, and since this is already going long, let me just show you an old example. And so, excuse you. Hey, show me the test. Yeah, let's look at this one. So it will so it runs through everything. It kind of shows you some of the output. You can like look at more output, and it's gonna go through everything. And then this is it. This is when it ran that unit test, and then it runs this, and then this is where it told us the Java version. Now this is where it actually ran LPT and some of the output, as you can see. And then I think this is where it errored out because I had red lines in my script, and yeah, so that's how that works. It's still running. It's still running. Actually, the last thing that I pushed is still building the system. But when it gets done, it's good. Yeah, see, it's done. Boom. It's building. It's building from the build file, and I'm sorry I keep snapping. My dog decided just now to start eating her food right next to me. So yeah, and then once it's done with this part, running the build. Oh my god. It actually already ran. So yeah, so it runs the build the it runs LPT, it runs the test script based off of that DSL file, and yeah, that's how that works. So yeah, that's the walkthrough of LPT. That's how it works. And let me know if you have any questions. I know this went pretty long. I'm sorry about that. But yeah, hopefully you fast forward to the parts that you thought were important. Yeah, bye.